it's always important before you start investing in lots of technology, and people tend to rush into having nice screens and all the fancy technologies, to ask some very basic questions when you're looking at precision farming. And one or two of the key things there to look at is, say, for example, the width of your drill. People say, well, it's a 6-metre drill, but for goodness sake, go and actually measure it and make sure that it is a 6-metre drill. It does what it says on the packet. Again, with cultivation equipment, make sure if it is a 8-metre or a 5-metre, that's what it actually does do in the field. The other things to consider is does the machine pull straight behind the tractor, for example? Quite often you go to this sort of situation and it's not actually pulling straight behind the tractor because it's got some coulters that are pulling it one way or another. So just check some of the basic physical things before we rush into the world of wonderful technology and pushing buttons, to make sure that we're doing the very best job we can, really, as far as precision is concerned. Other things to consider there is like the aspect of the land or the undulation. It's just have a consideration of that, because it does affect, as you'll see later on in the presentation, some of the decisions we might want to make.
So you're suggesting that my 6-metre drill is not 6 metres, and my 9-metre header may not be 9 metres?
It's a distinct possibility it might not be what it says on the packet, and therefore it's a good idea to go and measure it.
So just go and get a tape measure and work out what it is from there. So based on that sort of information, what can sort of technology and the machine side of things do for me?
Okay, I think it's worth just reminding ourselves of some of the key advantages as we see it, really, the way that precision farming can deliver, really. And we'll first look at the machinery, really, and obviously the first one is all about being more productive. We're not going to invest in this technology and get involved in here unless it has some key benefits in terms of productivity. So we're really talking about more hectares per hour and better work rates with this type of machine. And of course that comes really from having reduced overlap. And reduced overlap has many, many different benefits. We're not going to list them all here, but one of the key ones, apart from being more productive, is to reduce the amount of chemical usage and double dosing and fertiliser usage. That doesn't always happen at day one. It takes a few years to work out exact field sizes and then to adjust fertiliser and chemical rates, especially based on new information that the satellites might give us. But nevertheless, it's one of the key benefits and one of the major drivers why people get involved in this sort of technology. And then spin-offs, really, is it's all about less implement usage, because you're doing less runs across the field, less overlap, and therefore the wear and tear on the equipment, which has a genuine cost and advantage to you, is very important. And linked with that is fuel consumption. In fact, fuel consumption has emerged as one of the key drivers behind investing in this technology, because we recognise that up to 10 to 15% people often comment reduce fuel usage and therefore reduce tyre wear and depreciation and many other aspects to running the machine as well. A lot of people talk about forward speed, and it's definitely true that we can increase forward speed, especially in more visually sort of impaired times like dusty conditions or nighttime working, when things become a bit more tricky for the operator, who's often more tired as well, and this will definitely increase or maintain the same forward speed throughout the course of the day. And then finally, a lot of people start to make this comment once they've used the technology for a few years, they've got it maybe more incorporated in the whole farm, is that the machines and the tractors are definitely doing less hours per year. So there's lots more, Ian, but those are some of the key deliverables I think that GPS and precision farming can have on the machine itself.
Well, that's for the machine, and the machine's doing fewer hours per season. How does that, what's in it for the operator? Because if they're doing fewer hours, and that's great. Okay,
for some time I guess we've forgotten the operator a little bit, but I think it's very, very key now that he's a key stakeholder in precision farming. And anything we do here, we must involve the operator. And there's some really good benefits for the operator. Of course, the key one is that if you're not concentrating all day, you're not operating that steering wheel all day, you're not maintaining the same header width or the drill width or whatever, then he's going to experience less fatigue. And hopefully less fatigue will mean either a more efficient day or even a longer working day, whichever way you want to look at it. And that will increase his comfort. He'll be able to relax a little bit more, he'll have more time to spend doing other things, and his general comfort level will increase. And that might have advantages in his family life. It might not be the big thing he wants to do, depending on the quality of his family life, but it will improve his family life. It'll make it easier for him to work at night time and in dusty conditions. These are two very, very key benefits, because often he's getting tired, often he's getting fatigued by the end of the day, and maintaining the same level of effectiveness later in the day when it gets dark or when there's dusty conditions is very key. And then it's arguable, once you've again integrated this into a more broader farm basis, that the actual total labour requirement across the whole farm will actually reduce as well. That's a lot of people making those sort of comments now. And there's no doubt about it, we'll possibly get more skilled out of all operators, but I think the key point there is we'll definitely get more skill out of skilled operators. And the reason for that is he's not concentrating on driving all the time, and it will give him more time to optimise the rest of the equipment. A good example, I'd say, is on combines, where you're not concentrating on keeping that header full all the time. You have more time to look at the feed rate going through the machine, the tonnes per hour, and keeping that constant. If you can keep feed rate going through a combine constant, then we know we'll get a lot more output as a day or throughout the season. So there's some of the key. There's lots more, obviously, and more emerge as we get more used to this technology, but there's some of the key benefits for the operator, I think.
So before I start to spend too much time investing in actual equipment, I should be spending probably more time with my operator, working out and making sure that they're fully engaged in the system rather than just enforcing something on them.
Yeah, I think most people who've adopted this technology recognise that without the operator probably involved in the decision, certainly well trained and certainly you know, well equipped, if you like, to make the very best of this technology. If we don't involve him as a key stakeholder, then we're never going to get the best out of this technology.
Yeah. Before we start to go into the various details of what's available to me, how does this GPS sort of network and how do the systems work? Can you just refresh me on how it all works, please?
Yeah, not wishing to bog us all down in too much jargon and technical talk, but it's good to kind of just remind ourselves of what we're really talking about and what enables much of what we've been talking about today and we'll talk about this afternoon to take place. And it really revolves around satellite networks. And we all talk about GPS as being the kind of generic name for this, but actually GPS refers only to the North American satellite constellation. There's 24 of those usually that revolve around the Earth once a day, and that's the GPS network that we've kind of grown up with, really, if you like. But there are others emerging. For example, the Russian one, which has 17 satellite constellations, although this might change, but they won't tell us. This is called the GLONASS system, and in certain parts of the world they are using this now. Certainly some of our Eastern colleagues, Eastern European colleagues are well versed in this network. And then the planned one is the Galileo one, which is the planned European one. They're talking about 30 satellites for that one. And when we group these three things, and others will emerge as time goes on, when we group these three together, we call them the G3 technology. It's a little bit of jargon for us. Another name would be the GNSS. Doesn't trip off the tongue quite like GPS, but that's the real name for the whole three systems, the global navigation satellite systems. And of course, what we know is that the GPS one, the North American one, is the one that we're all probably using in this room. It's most widely used, and I suggest for the time being that's where we'll all remain.